Hello students, how are you all? So I'm going to start a playlist on YouTube where I will be covering all the important questions of this very popular book. नाम तो सुना होगा ना? Okay. मेरी तो काफ़ी favorite book है ये. So we are going to start that playlist. So in that playlist what I'm going to do is that in each video I will be discussing one question. Okay, and I will be taking those questions which are very important and relevant from the JEE Advanced and Mains examinations. So in each video I will be discussing one question along with its concept. So you can go through all the important questions that I have discussed in this video, and it will become very helpful for you in your preparation for JEE Advanced. Okay, so without further ado, let's start with the electrodynamics part. So I'll be starting with the electrodynamics part. Now if you go through this question, it says that wire is bent in the form of a parabola y equal to ax square. So we have wire bent in the form of a parabola y equal to ax square. So this is our wire. Now in this wire we have magnetic field present in this plane perpendicular to the plane. So cross of magnetic field is present everywhere, and on this wire we have a slider here, and we are moving this slider upward. Okay, this slider is moving upward. Acceleration W. So this is the acceleration of the slider upward. The slider is moving upward on this parabola. Okay. Now EMF, we need to find induced EMF as a function of y. So if you talk about from here to here, distance is y. So what is the induced EMF? Okay. Let's approach this question. Now EMF formula is, if you have to find induced EMF, we need negative of d phi by dt. So we need rate of change of flux. Okay, so rate of change of flux is required. Now flux we know how to define. So flux is given as magnetic field into area. But the problem is that when the rod is moving away, this area inside the rod, it will change, and magnetic field is constant. So we have to calculate the area, and then we need the rate of change of area. Okay, so we can simply calculate the area and differentiate the area multiplied with magnetic field. So let's start. Now for this one, what I will do, I will take an element of width dy at y distance from the base. At y distance we calculated the element dy. Okay, now so if I talk about elemental area will be integral of, see, this height is the x coordinate, and width we have already taken how much, dy. So this can be assumed as a rectangle. If this side is x, so this side will also be x. So what will be the total length? 2x. So 2x, and height will be width will be dy. So 2x into dy, that will be our elemental area. Okay, now let's integrate it, putting the values. 2 times the value of x we can calculate from here. So x is how much, root over y by a into dy, and limit again we need to put 0 to y because we need as a function of y. Okay, now 2 root a outside, here y power half, so it will become y power 3 by 2, and here will be 2 by 3. So we got 4 by 3 root a and y power 3 by 2. This is our total area. Okay, now flux. So flux will be given by field into area. Magnetic field is there, area we have calculated. Area will be 4 by 3 root a and y power 3 by 2. This is our flux. So induced EMF formula is rate of change of flux, just the magnitude we are writing. So d phi by dt. Now we're going to differentiate it. So 4 by 3 or 4b by 3 root a, y power 3 by 2. So it will become 3 by 2, y power 1 by 2, and then dy by dt. Okay, now 4b upon 3 will get cancelled, so it will become 2b by root a y power half into dy by dt is what? Velocity. Now see, dy by dt is the velocity of the rod at that instant. Now acceleration of the rod is given how much? Acceleration is given w. Okay, acceleration is given as dv by dt, that will be w. So dv will be how much? W into dt. Since acceleration is constant, so velocity we can write down how much? W into t. Okay, so velocity will be how much? W into t. Now if you talk about distance covered in y direction, so it is going with acceleration. So initial distance 0, so it is sliding upward. So we can apply this formula, half a t square half w t square. So in place of time, what I can write? In place of time I can write 2y by w. Okay, and so velocity will become how much? W into t, w into t, so it will become 2y w. Okay, now let's formulate. Let's simplify this formula. So root a y, so here we have y power half, that's okay. Instead of velocity we can write what? 2y w. Okay, so induced EMF will come b root over 2 y power, how much will have? 1 by 2 plus 1 by 2, so only y power y will come. Okay, let's simplify it. B, see here we'll get 2w by a into y. So this is our induced EMF as a function of y. Induced EMF as a function of y, it depends on y directly. Okay, sorry, it was not visible. Okay, so this is our induced EMF as a function of y. Okay, again just a last time revision. So this railing was moving upward with acceleration w. So equation of this parabola was y equal to ax square. So we needed induced EMF as a function of y. So we tried to calculate this area. Okay, now this area, for this area we take an element at distance y, we take an element of dy. So length of this element will be x this side, x this side. Total length will be 2x and width will be y. So 2x and width will be dy. So we integrated this one, we got the area. Now flux is given as filled into area. So we put the value, we got the value of flux. Now we have to differentiate this flux. So while differentiating, we will get this expression. Yes, this is our expression, 2b by a y power half into velocity. Now for velocity, what I did, we integrated using the acceleration equation. Acceleration is w, acceleration is given as rate of change of velocity. So acceleration is rate of change of velocity. So dv by dt will be w. So integral of dv will be integral of w. So velocity will be w into t. W is acceleration. Clear? Now velocity is w into 2. Now distance covered in y direction will be given by half a t square, because the rod starts from rest, goes up, so it accelerates up, right? So distance will be, second equation of motion, ut plus half a t square, u is 0, so it will be half a t square. Now time will become how much? Root 2y by w. Okay, now if time is there, we'll put the velocity equation. Velocity is w into t and time is this much, so this is our velocity, root 2 yw. So this is our velocity, root 2 yw. Just put the value of velocity here and simplify the expression, and we will get the value of induced EMF. So induced EMF b root over 2w by a into y. So induced EMF directly proportional to y distance. Okay, see you in the next video.